What's poppin', dogs? Mr. Allen here with Algebra 2 Honors Semester 2 Review. We're on Module 2, Topic 3, Solving Rational Equations Review. And we've just been having so much fun here. We're going to keep that fun rolling here with, I believe, a third video now for this review. It's epic, man. All right, so we want to find the values of x that make the expressions undefined. What makes it undefined? 0 in my denominator. So the only thing I need to do here is factor that denom, right? So what multiplies to negative 14 and adds to negative 5? Negative 7 and positive 2. You guessed it. Well done, guys. So the x values that make it undefined, we would say 7 and negative 2. Those are the two x values that make it undefined. Oftentimes, you're going to see it written as like x cannot equal 7 and 2, and perhaps I'll even just throw like a little comma there, right? So those are my two x values that would be like, no bueno, not good. All right, next one here. Oh boy, what's going on here, man? We got x squared minus x. Now, if you're thinking here, like, I'm going to cancel those x squareds, I'm going to scream it through the computer right now. I'm going to lose my cool, right? And it's not going to be good. So we don't want that. You can't do that. You'll never be able to do that. But what we can do is we can factor our denominator, because that's the only thing we're also focused on right now. And I'm going to have x minus 1. Now, if you were thinking, well, why do I need that minus 1 there? I took the whole x out. Well, we need a placeholder for that minus x, that negative x. So please make sure you have minus 1 right there, all right? Dope stuff. I was going to say dope stuff and dope sauce, and I don't know how that came out. Anyways, so that's my denominator. What values would make that undefined? Well, it'd be 0 for that one and positive 1 for that one. So x would not be able to equal 0 or 1, right? There we go. So I'm kind of writing it in like more of like a domain restriction way, because that feels right. But it's 0 and 1 would be the two values that would make it undefined. All right. Next up, we want to perform the indicated operation. All right, I'm going to forego talking about domain restrictions here unless we asked for it, right? Then I'm not going to worry about it. It's a whole lot. Okay, so I'm going to focus on just the performing the indicated operation for these. Okay. So for that first one there, let's see, we got to get a lot of factoring done, okay? Tons of factoring. So I got k squared minus 36. That's going to be k plus 6 and k minus 6. Who decided to throw k's in here, bro? It's x's or bus, you know what I mean? Like, don't you hate when we do that? Okay, I mean, I guess I made the review, but whatever. I didn't change it. I'm sorry. I apologize. So we got k plus 8, and we got k minus 3, so that's cool. Now, this next part here, I'm going to do a little side math to save some space on that guy right there that I just completely blocked out. So this right here, actually, we can write it all in one step. I don't want to confuse you guys. I don't know what I'm saying. All right, so I'm going to take out a negative, okay? And I'm going to be left with k squared plus 2k minus 48, okay? So I want to rearrange it into standard form there, highest degree down, and I do not want a negative lead coefficient on my k squared term, okay? We don't want that. We do not want that. No one has ever in the history of time factored successfully with a negative lead coefficient. It's impossible. Landing on the moon is easier than that, okay? So now that we got that all cleared, let's factor that one up, okay? So I'm just going to do that right below it. We're going to have negative, and we got k. And then it would be, let's see here, what multiplies to negative 48 adds to 2? What? Oh my God. It's going to be 8 and negative 6. Okay, so we got k minus 6. There we go. So that's what I'm going to be dealing with there. All right, a little squiggly out it. We got it. It's all factored. Now we can cancel some things. So I'm going to go light blue with this one. I'm feeling the light blue on my cancellations. K minus 6 is gone. K plus 8 is gone. That's it. That's all that's gone. So now I have a negative still. Don't forget that negative. And then I have k plus 6 over k minus 3. That would be my final answer. Don't forget that negative. That'd be unfortunate, because then there's going to be a negative 1 or minus 0.5. Well, in this case, it'd be all wrong if it's multiple choice. So definitely don't forget that. Okay. Number 4 here. Ooh, division. Division. Do you guys remember what to do with division? Very good. Thank you so much for answering me so quickly. You're gonna do the reciprocal of the second one and change it to multiplication. And if you say keep, change, flip, oh my goodness, I'm gonna get so upset right now, right? You're just probably saying that in your head just to make me mad. I'm getting upset here. I'm getting frustrated. All right, 6n minus 30. People love their little sayings. Keep, change, flip. Come on. We're gonna multiply by the reciprocal. Okay, I'm using big boy terms, right? Adult math terms, right? Okay, so now I'm gonna factor out that GCF of that 6 there. I got 6, and then we have n minus 5 over 6 times n plus 2 over n minus 5. Now, what can we cancel? Well, I can cancel these n minus 5s. I'm going to go light blue with the cancel again. And these 6s can cancel. What does that leave me with? It leaves me with n plus 2 and that is in my numerator. So my final answer is just n plus 2. Had that n plus 2 been in the denominator, then we would have 1 over n plus 2. Fun fact, just in case you run into it in the future. I don't know, man. Maybe you will. Who knows? We'll see. I really don't know because this is the first time I'm keying this. So again, if I make any mistakes in here, please shoot me an email, find me in the halls, and be like, Mr. Al, you made a mistake. I think, right? Because it's always a little intimidating to go ask somebody if they made a mistake when you perceive them as knowing more than you in math. It happens to me too. When I go ask Mr. Kalis, I'm like, Mr. Kalis, is this a mistake on your calculus key? That's a bold move to call him out, right? I think it's happened once, right? And I've asked a few times, but hey, never hurts to ask, right? Okay, let's continue. So, and if you do happen to find a mistake, I'm going to give you that YOLO sticker. You only round once. Okay. So here, let's see here. Multiply by the reciprocal, right? There's no factoring with this one. So those of you that are not factor fans, this problem's for you, man, right? So we just got that. Okay, cool. These guys are going to go. I'm going to use the light blue on the cancellations. And we're right back. We got 16x squared over x plus 7. There's nothing else I can do here, bro. Nothing else I can do. That is our final answer. Beautiful and fantastic. Okay. Let's see here. Next one. My goodness. I got to flip and multiply by my reciprocal once again. I feel like I'm hearing something. I don't know. I feel bad if any of my neighbors are out and they're like, what is this guy doing? Why is he doing math? And got this bit. I got the whole microphone set up, bro. Like, I want to sound good, you know, right? I don't want low quality, right? I even got the fancy webcam. I can't show you the webcam because it's the part that's recording, but all right. So we got 5 over r plus 4 times, and I'm going to get the, I'm going to factor on the fly, bro. I got r plus 6, r plus 4. Again, these crazy variables, man. R's, K's. I mean, we're all over the place. That was a weird looking 6. All right, there we go. So now can we simplify? Oh, heck yeah. Bring out that light blue, baby. Bring out that light blue. Oh my goodness, why isn't it letting me select the light blue? This is upsetting. I'm really trying hard right now, but it's not letting me do it. Hold on. My goodness, it's just not going to let me do it, man. So we're going to cancel there. We got that one and that one, and I'm just left with 5. Lovely. That's beautiful. I was able to get the light blue working there when I hit the pause, so we're okay now, guys. We're okay. All right. Beautiful. Fantastic. 5's our answer. It was in the numerator, right? If it was in the denominator, 1 over 5. Okay. Now, oh my goodness. We're going to do addition and subtraction. Oh, God. Multiplication, division. That's easy street, baby. But addition, subtraction with non-like denominators. Oh, boy. Here come the mathematical tears. All right. So my denominators are totally different. I need to multiply this first one by 4 over 4, and this one by x minus 1 over x minus 1. So my first one, I'm going to have 24 over 4 times x minus 1, and my other one, I'm going to have 5x times x minus 1 over 4 times x minus 1. And why don't I go ahead and, maybe I'll just distribute that 5x minus 1 right in there. Let me just do that. Okay. So we're going to have 5x squared, right? And then I will have the minus 5x. Okay. So now what we got to do is we got to be careful because we are subtracting. This negative applies to both of these. So what we're going to have is 24 minus 5x squared plus 5x all over 4 times x minus 1. And I'm just going to go ahead and rearrange this. Negative 5x squared plus 5x plus 24 over that 4 times x minus 1. You can multiply that 4 times x minus 1 out or just leave it like this. I'm going to say leave it. Much easier, right? Okay, next one here. We got, again, totally different denominators. The x's there are not like parts there because they're not factors, okay? So I have to multiply this one by x minus 8 and x minus 8, right? That fraction. And I've got x plus 7 over x plus 7. So now I'm going to have 3, and I'll write this one out because we got a lot going on, I feel like, minus 8, and then, 3 times x minus 8, and then we got 4 times x plus 7. All right, and I'm going to distribute here before writing my denominator back in. We got 3x minus 24 plus 4x plus 28. And then I can actually combine like terms. I got 7x plus 4. And now I'll go ahead and bring back the x minus 8x plus 7. Don't forget that. Like, I'm doing some stuff to save a little bit of time and some writing there. But be very careful, when you're pulling that kind of fancy mathematics, right? You know, this, I mean, I'm doing some math on the streets, right? It's not necessarily the most proper way of doing it, right? But I'm doing my own thing there. I'm getting the right answer. I'm working with the things that are changing, right? But I know I got to put that denominator, the x minus 8 times x plus 7, back in there, okay? So be careful with that if you're doing street math, but otherwise, that's dope. Whew. This is a lengthy video, right? I'm getting a little tired here. All right, dogs, now we are into solving here. And there's a few different scenarios with solving and different styles of solving, right? If I've got a fraction equal to a fraction, I'm going to cross multiply that bad boy because that's just the easiest way to go about it. Some people don't like to do that, but I like to do that, and guess who's making the video? It's me. So I got 4 times x plus 5 equals, and then I've got 8 times x, so 8x. Then I'm going to distribute, right? I'll distribute that 4 in. So I'm going to have 4x plus 20 equals 8x. I'm going to subtract 4x on both sides, right? Keep x positive that way. And I got 20 equals 4x. So we're going to get x equals, after I divide by 4, I'll show my work. I'll show my work, right? Rihanna loves to show her work. Okay. So then I'm going to have x equals 5. Beautiful. There is my solution. All right. Now, it does say to check for extraneous solutions. So when we check for those extraneous solutions, we got to plug it back into the original and see if it causes the denominator to equal 0. The denominator is 8 and 4. No problems there, right? I'm just going to be plugging 5 into my numerators. We are all Gucci. All right, next one. Again, a fraction equals a fraction, so I can cross multiply. I'm going to have x plus 4 times x minus 3 equals negative 3x. Now, my left side, I got to FOIL that bad boy out. X squared plus, let's go with the x distributing first, all right? I don't want to confuse anybody. Minus 3x plus 4x minus 12 equals negative 3x. So x squared, let's see here, plus x minus 12. Oh, my goodness. I have a quadratic here, guys. That's crazy. I'm going to have to factor. So we're going to add 3x on both sides here. Add 3x. So I'm going to get x squared plus 4x minus 12. At least I hope we're going to be able to factor, right? Because otherwise it's quadratic formula, baby. I don't want to bust that out. All right, we can factor this. So we got x plus 6, x minus 2. That multiplies to negative 12 and adds to positive 4. So that means I'm going to get x equals negative 6 and x equals positive 2. Would either of those cause a 0 in my denominator of the original? No. So that means that both of these solutions are Gucci. We are all set, and it's dope. Okay. What are all these P's, man? We got a lot of P's here for this one. It's stressing me out. All right. So for these, what we want to do is we want to get ourselves you can either get a common denominator or try to eliminate your denominator. I've seen a lot of people go the route of the getting the common denominator and then just working with our numerators. So that's the route that I'm going to go with this one. So I think it's worked well for everybody. First thing I got to do, though, is factor my denominator. So I'm going to factor a P out, and I'm left with P plus 1. Same goes with this one here, P times P plus 1. And then over here, I just have a P plus 1. Well, it's pretty clear what I need here to make them all look alike. This guy needs a P over P, right? P divided by P. So now what I'm going to have is this, okay? We're going to have P plus, actually, I might need a little more room. Let me back that thing up. All right, P plus 5 over P times P plus 1 equals, and then I have 1 over P times P plus 1, and then I have minus P times P minus 6 over P times P plus 1. All right, so do I have all the same denominators here? Yes, they're all P times P plus 1. And it might be helpful here, since we are solving, I'm going to go ahead and write my domain restrictions here. P cannot equal 0 or negative 1. So we'll go ahead and write those down, okay? So now, let's see here. Where was I? There we go. All right. So all my denominators are the same. Yes? Yes. So would it make sense that I can just work with my numerators, right, and get that all to be equal? Yes, it would. So I'm going to have P plus 5 equals 1 minus P times P minus 6. There we go. I'm going to distribute, so I get P plus 5 equals 1 minus P squared plus 6p, and then I'm going to bring everything over to one side, okay? So I'm going to have p squared minus 5p plus 4 equals 0. I had to subtract 1, I had to add the p squared, and I had to subtract 6p. I didn't have a whole lot of room, so that's why I did that all without writing everything down. Apologize. All right, so now I'm going to factor this thing. So I got P, it's going to be minus 4 and minus 1. So minus 4 and P minus 1 equals 0. So I'm going to have my answers of P equals 0 and P, sorry, not P equals 0, P equals, oh my goodness, P equals 4, right? And P equals positive 1. Now, are either of those in my domain restrictions? No, 0 and negative 1 were my domain restrictions, so no extraneous here, which is super duper dope, right? Though I'm kind of waiting for one of those extraneous solutions. It feels so crazy, you know? It's not really that crazy. Okay, let us continue here with number 12. Oh, it's the last one of this topic. I'm kind of excited for that because it was getting a little long there. All right, so I got a factor first. We got x times x plus 2 for this one, and that's all the factoring I can do. So now I got to get common denominators here, right? I'm going to think of this 1 as like a 1 over 1. That might be helpful. And I'm going to multiply. My far right fraction needs an x plus 2. Was that a little voice crack? I think it was, but it's okay. I'll leave it in. All right, that one's going to need an x plus 2 over x plus 2, so I get the like denominator. All right, and the other one needs the whole shebang, right? X times x plus 2 over x times x plus 2. Why is it legal again to multiply, right? It's because if I multiply numerator and denominator by the same thing, what's anything divided by itself? It's 1. What's anything times 1? That anything. So we aren't really changing anything. It's going to look different, but it's still mathematically equivalent. Okay. Let us continue after that mathematical fun factoid, right? So now what I have is on the left-hand side, we have x times x plus 2 over x times x plus 2. I'm going to shift this up a little bit because I feel like I'm going to run out of space otherwise. Oh my goodness, magic. All right, there we go. Back to blue. Okay, so then equals, and then I've got 1 over x times x plus 2. That one didn't change. And then we have plus, and we have x minus 1 times x plus 2 over x times x plus 2. So are all my denominators the same? Now it is, because I have that other parenthesis. Ooh, I forgot one in class today, man. I felt kind of bad about it, but then we caught it. But it was just, it's terrible looking. All right, so all my denominators are the same. So if I set my numerators equal, we Gucci. All right, so I got x times x plus 2 equals 1 plus x minus 1 times x plus 2. And now I'm going to do some foiling, some distributing. Oh, my goodness. So we got x squared plus 2x equals 1 plus, now I'm going to have x squared. I'm going to foil this thing and combine like terms on the fly. It's going to be crazy. I got 2x and negative 1x, which is going to give me positive 1x minus 2. Did we follow? Okay, cool. I don't know because I can't hear you. Those are going to cancel out. Right? That's kind of nice because then I'm not going to have any factoring there. And then I've got, let's see here, I got to subtract x, so I'm going to get, I'll show that, 1x, subtract x. I got x equals, and then we got 1 and negative 2, so I got, what, negative 1? Oh, that's it. Cool. Yay. All right, now one thing I did forget to write down here up at the top, let's go ahead and throw our domain restrictions, right? X cannot equal 0 and negative 2 for my domain restrictions. Now that x equals negative 1 is not one of those, so we are all good. Not an extraneous solution. Man, made it through with no extraneous solutions. That's pretty dope, though. All right, guys, that's it for that one. On to Module 3, Topic 1 in the next dope vid.